And I'm concerned for a couple of reasons. One reason I'm concerned right now is I know that for a fact that I watch a lot of college football and pro football. I love football. I watch a lot of high school football. I enjoy it very, very much. And I watch it, and I watch it, and I watch it. Now, I will tell you this. Because of the benefit of my television, as well as most of your televisions, I can rewind stuff and rewatch it and make the right call every time. Pretty amazing. Pretty amazing. Now, with the amount of football that I do watch, I probably should be an outstanding football player.
Well, I'm really good at major leagues. Like
NFL.
NFL.
Yes. I should be. I should be unbelievable. I mean, there's 3 different perfect spots for me to sit in my family room to watch football. Now, I have a perfect spot during our high school games, usually around the 20 to 25-yard line on our side of the field, watching the game. I should be better at high school football, seeing the calls, making the calls, but unfortunately, me being 5'9" and a quarter, I can't always see over some of the people who are in the way on the field. Yo.
You should tell them the story about how you were a varsity football player.
Well, I could do that. I wasn't that good of a varsity football player, though. Do you guys know that I made varsity football my sophomore year in high school?
Was that because no one was?
No, it was my story. I got to tell that right away. Yeah, it was basically, because everyone hated the new coach, so all the guys who were juniors and seniors all quit. And so me being a sophomore, it's like, okay, now you get to play varsity defensive line. Okay, now, I wasn't any taller than I am right now. I did weigh a little bit more. I weighed 217 pounds. Right now I weigh 175, so I had a little extra girth to me. Boy, I was not good. And in no way, shape, or form deserved to be a varsity football player because I had talent as a sophomore in high school. But here's the thing. My point is, by me just watching all of the football that I happen to watch, there is no way that I could step onto a high school field, a college field, or a pro field and do anything good. I cannot run any of those guys. I'm more than likely, maybe if I was lucky, one of the smaller punters in the NFL, maybe I could tackle. I'll go with the punter. That's about it. I sure in heck wouldn't do well getting my eye poked. That would hurt. I'd probably cry. But my point is, by me watching and watching and watching, I'm never going to become good. But a lot of you will watch and hear. Now, I'm not going to tell you every one of you is going to go become a mathematician. It's not really all that it adds up to be. You know, one thing that I learned early in life is there's 3 kinds of people in the world. Those who can do math and those who can't.
That's the point.
You didn't get the joke. I was like, God, that's horrible.
I got it.
So, my point is, I looked at these quizzes, not as a grading standpoint, but just kind of a thumb-through glance. And my heart tells me, don't grade them because that score, one, it was a Monday. Yes, it was Monday. Sorry I gave it to you on a Monday. But Monday is one of the days of the week. It is fair game to give a test or quiz, which I did tell you all about. But some of you might have just chosen to observe on Friday and not do anything on Friday. And that makes it tough because you only observe. And the observations were obvious when it came. Hey, Steve! Reminded me to unmark you from being absent. Oh, yeah, I should put that right here. Perfect. Next man. So I want to hand these back to you ungraded. Now, some of you aren't here, so I actually wrote your name on yours and yours blank because you weren't here, and that's okay. But I want to go through these, and I want you to feel, you know, the two that just came out that were blank, actually, I just want you to realize, let's go through it, let's do it, let's focus on it, let's figure it out. So you don't have to. But let's get this right. And those of you that know that you didn't do well on this, it's kind of obvious. And some of you, you find some unbelievable arbitrary numbers, which is unbelievable. I love it. But when I lived in Vegas, with the amount of times I stood at the craps table watching dice being thrown, should have made me an unbelievable craps table player. But the problem with the game of craps is it's a game of chance, and everything in Las Vegas has the odds stacked against you. Okay? Meaning the casino is set up in a way to make money. And I'll give you just an easy one to think about. The probability of you rolling a 12, which is a 6 and a 6, with a pair of dice, is 1 out of 36. In order to make that a fair bet, that would mean if you bet $1, they would pay you $36. The problem is, they pay you back 18 to 1 on it. So for every $1 you bet, they pay you back 18. But the odds have it, the probability of you getting a true good score versus not is taking it away from you. Let's see. Yo. Oh, stretch here. That you. Did everyone get one back now? Did I forget anybody? Again, no, please note, I didn't grade it. But this is what I want you to do, is I want you to go through and grade it after you do it. Okay, problem number 1. Pretty simple problem. Do you agree? Find the slope. Slope equation is the y's being subtracted over the x's being subtracted, correct? Okay, so we have this as an equation. Now, this is where I think people start getting hung up on this equation. You're like, oh my gosh, is it y1 first or is it y2 first? Right, this equation is actually the exact same as me doing this. It's the exact same thing. I'm just calling it x1 and y1 and x2 and y2 to identify that I am using 2 different points. And as long as I plug it in correctly. But I saw some of you, just on this, it was like, you know, I had people going, 58. And I'd be looking at it going, where did that even come from? Like going, okay, did they just multiply all the numbers together? Because sometimes, you know, there might be a scheme that you had a thought process that you thought was right, and I was like, okay, how did they get 58? Is 3 times 2 times 5 times 6 58? No. Is 3 times 2 times 5 divided by 6 58? No. Is 3 divided by 2 times 5 times 6 50? I couldn't figure out any combination of 3, 2, 5, and 6 in order to get 58. Okay? And I'm saying this with a little bit of sarcasm, but I'm also saying with it, saying, hey, picking a number out of an infinite amount of numbers isn't the best way to approach math. Okay? You have infinite numbers. The amount of numbers that lie between 0 and 1 is infinite. Okay? Meaning, you can take half of any fraction. You can find a decimal smaller. So, doing this problem, I'm going to take the y values, and I'm going to take the x values. Wait. 6 minus 2, 5 minus 3, sorry. Is that right? 6 minus 2 is 4 over 2, which is 2, over 1, which is 2. So, I'm not sure where the number 58 would have come from for this problem. And again, I wanted to give people the benefit of the doubt going, was there a mathematical algorithm that was taking place to get there? Now, this is what scared me. There are two people that had an answer of 58 that sit next to each other. Help me out here. Did one person pick 58 out of an infinite region of numbers, and a second person also pick 58 out of an infinite amount of numbers? No, someone was like, I don't know what the hell to do. 58, oh, it's a number. That's got to be right. You ever heard the term, the blind leading the blind? Okay, someone who can't see, helping somebody else who can't see navigate is not the best navigation process. Okay, so and I'm just saying that there is a really small probability that two people selected the number 58. But I will also tell you, we all have a better chance of all of us getting struck by lightning 4 or 5 times during this class period right now than two different people selecting the number 58 at random who sit next to each other. Yeah?
Could you just have kept the answers for the two?
Absolutely. I would totally accept that. As far as slope goes, absolutely. Okay? Then, so let's look at number 2, number 3, and number 4. Now, things that most people will identify with 3, 4, or 2, 3, and 4 is you have x and y in both of them. Now, 3 is already set up nice and neat, so we can find the slope to be -7. We can find the y-intercept to be 12. Okay? Number 3, we tried to trick you. We put it out of order. And I will tell you that there's a lot of you that flip-flopped what slope and y-intercept were because you were like, well, the order has to be this. No, the slope of this one is -1/2. The y-intercept is 2. Okay, so hang on. So that pattern right there between the two would be whatever is attached to the x component is the slope. And whatever the constant is would be the y-intercept. But what's different about this problem than the others? Y is not by itself, so let's get y by itself. So my first move would be this. And what I would have done to both sides is subtract 2x from both sides. And then I had to realize I have to divide both sides by 4. And then I have to say negative over negative is positive. So then I get y equals 1/2 x. Okay, and then I can reduce it. And then 8 over -4 is -2. So then my slope is 1/2. My y-intercept is -2. Okay? That's really all I had to do with it. And now some of you are sitting there going, that's all it was? The person sitting there with 58 is going, oh. And then the other person who's got 58 for an answer might be looking at the person that they got the original 58 from, going, dude, you're dumb. I'm just saying that, being funny. All right. Now, while y'all are looking around, trying to figure out who in the heck the two culprits were that both had 58, it was fictitious. I made it up. But I've seen that kind of helping take place where you have somebody who is so blatantly wrong with an answer that the person next to him also copied the so blatantly wrong answer.
Oh wait,
Yeah.
I actually have something I can say on this because I'm on grade papers. She's a science teacher in Aurora, and I think you know how well Aurora is,
8-town, sometimes, yeah.
or isn't.
I understand.
Most of her kids don't speak English, but the ones that do tend to quote unquote help each other.
Mhm.
And we had a page full of identifying what the atomic number, atomic mass, and symbols were when they had their periodic table with them. There's these two kids that sit next to each other, and they all wrote down the names, not the symbol,
Yep.
not the weight, not the mass, just it's all the names, and it's not even the right names.
I understand. I understand. God loves the children. You know that. And we just. And I'm saying that, and I'm not trying to go religious. I'm just saying, you gotta love people. All right. So let's go through these problems. Now, the only other equation that had to come along for the ride on this is this equation. So what we want to do is we want to set this equation up. And these three problems we can use that equation on. So the first one is already set up very nicely to give me an answer of this. And now you get the, well, how do you know where M and B go? Well, M is right there next to the X, and B is added.
That's the answer.
Uh-huh. Okay, now, this next one, do I know the slope?
Yes.
So, now here's a quick question. This next one, do I happen to know the y-intercept?
Yeah.
Why do I know the y-intercept on this next one? Yeah, I mean, if you graph this, 0, -5, that's that point. Is that point where it crosses the y-axis? It lies right on it. So this, as it sits, happens to be B. So this one I can do y equals -3x minus 5, or plus -5. Okay? Now, that's just if you recognize 0, -5 being your y-intercept.
So you don't have to do 0.
Well, I could have, and it would have given me the exact same answer.
Would you
But
put 5 in 0, or would
you would put 0 in for x on the original equation.
oh, okay.
So if I were to do this, I would realize this is x, this is y. I would have plugged it into there. I would have went -5 equals -3, because that's the slope, times 0 plus b. So b is equal to -5. And that's how you could have approached this problem if you worked it out. Okay? Now this last problem, I have an x, I have a y. Agree? I'm going to use that equation to solve for what value? Well, I have m, I have y, I have x. What's the only one left? The plus sign. Good. No, the equal sign. No, b. So y equals mx plus b, I'm going to plug back into.
So it was the plus sign.
It's the guilty one. All right, so -half of 4 is -2. Careful on the sign. And then I find that b is equal to 7. Now, I want to take m and I want to take b and plug it back into the original equation, which is located in the upper right-hand side of the board. So m is what? -half. And b we just found to be 7. So +7. Done. What do you think? That's it. Can I clear that? Feeling okay about it? Clear and ink. All right. The next 3 problems, we are going to use, oops, that's a 1. to 0. All right, 8, 9, and 10. 8, 9, and 10. All right, I'm going to take 1 and plug it in for x on the first one.
That's a very fancy.
Okay, the next one, I'm going to plug negative 2 in for x. Last one, I'm going to plug 0 in for x. Notice where the x sat is now whatever number is in the f at, or the g at. So do the math. 3 times 1 minus 1, 3 minus 1, 2. This is my answer. This is the point, 1 comma 2. How do I know that the 1 comes first? Plugged in where? What? Say where? Not just up there. Where? In the x. That's it. So I plugged in for x 1. Okay, this next one, that becomes 3 times 4 minus 1. That gives me 12 minus 1, which is 11. So that's the answer. This is the point negative 2 comma 11. Again, how do I know the negative 2 is my x component? Because I plugged it in for? Yeah, buddy. And then last one. That's 3 times 0 minus 1. That's 0 minus 1, which is negative 1. So that's my answer. The point that goes with this is that. No, I'm trying to get just a little bit further along level.
I plugged them all in, right? I just got all the answers.
Okay, so arithmetic's the tougher part for you. So, just so you all know, if I had f at smiley face, that would mean this gets plugged in like that. I mean, that's all I'm doing is I'm substituting in. I'm creating my x. I'm calling it the input. I'm putting something in. I'm getting output out. I'm putting an x in. I'm getting the y out. I'm putting an x in. I'm getting the function at x out. So those are all the same thing. Okay? Let me clear these. Next, I'm going to use g at t. Again, this is functional notation. So I want g at negative 1. I want g at half. I want g at 0. And then I want to know what t is equal to when g at t is equal to 1. So this one's a little different. Okay? This one I'm going to plug negative 1 in here. This one I'm going to plug half in here. This one I'm going to plug 0 in here. Okay, so let's do the easier ones. So that's 4 plus 1, which is 5. This yields me the point negative 1 comma 5. This one is negative 2 plus 1, which is that. This yields me the point 1/2 comma negative 1. Okay, again, these are the answers I was looking for. This one is negative 0 or 0 plus 1, which is going to give me positive 1. So this gives me the point 0 comma 1. Okay? The last one, I'm plugging in 1 where? Yeah, I know this. I know that g at t is equal to 1. G at t is this. What goes in right here now? What goes in right there? 1. So I get 1 equals negative 4t plus 1. Solve it. Subtract 1. Divide by negative 4. Okay, so this answer, this is actually the value of y. So 1 goes there. What goes where the x is? And we're calling it t right now. 0. Okay, so that's the answer. Backside. Backside was a neat adventure. Backside was a pretty neat adventure. No, not yet. All right. So the first problem, we get a graph that looks kind of like that, where they tell us that this, it looks like it's at 0, negative 5. We know like right here, that's the point 5 comma 0. And we know this point right here is negative 5 comma 0. Okay, and I'm just getting those points from the graph rather than drawing the whole graph. So they want to know, they want us to say what the domain is. Okay? These are the x values. So I want you to think about this. And this is as simple as I can make it. If I am driving a car along the x-axis with that graph that's somewhere superimposed on the x-axis, you still with me in this adventure? If I'm driving a car, so I started way out that way, and I'm going to go way out that way. If I were to drive the car and I were to look up or down or right on the road, does the graph stay continuous? Or is there anywhere where, oh, I don't see a graph anywhere? Yeah, I can go forever left, forever right and left. Actually, forever right and left. I can't do that. Forever right and left, basically, I'm not there. This is here. To that point, to that point. I can drive forever and ever and ever and ever. And no matter where I drive to on the horizontal plane, the graph exists either above me, below me, or right on the line. So my domain goes from negative infinity to positive infinity. It doesn't stop. It does change direction, but that has nothing to do with domain. Which means I can sit there and plug an x value in, no matter what I want, to whatever the function is, to get a y value out. Okay? And then we wanted to know about the range.
Right, so as long as you put -6.
No, because the arrows keep it going. It didn't start and stop at -6. It went forever left and forever right, so it's negative or positive infinity. The range deals with the y-axis. So this is like an elevator. So this is the y-axis as far as this problem goes. Okay? If I were to ride an elevator forever downward, does the graph still exist on both sides of me? Or one side of me to the other? The graph.
Oh, this is
I probably did. So if I take an elevator ride down. So if I'm in this elevator, let's just pretend I'm in an elevator, and I'm going up and down. What happens with the elevators down here? Can I look out the window to the right or to the left and still see the graph when I'm down here below the graph? No. What about here? The elevator gets here. Can I see the graph? Yeah, I see a point. And then I start going upward, and I start seeing a point on one side and the other because the graph exists that way. So the range of this particular graph is going to start at -5, and it's going to go to positive infinity. And I'm using a square bracket at -5 because it's starting at -5. If I go to -6 and I look out the window on either side of the graph, I don't see a graph. I don't see the picture anymore. Okay? And then we want to know, hey, when is this increasing? Increasing means it's kind of ending towards the upper right. So this is the region that it's increasing. So I'm going to look at the x portions only. So it's increasing, starting to increase at 0. And where does this arrow indicate I'm going to get to? Positive infinity. So I'm increasing from 0 to infinity. And then the last part of this is I want to know where I am decreasing. So decreasing would either be coming down this way or it would be growing left, which means the same thing. So where do you think? 0 to where? Again, those are both x portions. In the x direction, if I'm cruising along, I get to right here in my car, and my car is going this way or this way. As my car goes this way, I am increasing. As my car goes this way, I am decreasing. Okay? Can I move on? So this one changed directions. Then we gave you a little curveball. And it appears that this is the point -4, 0. This appears to be -3, 3. This appears to be -1, 0. This one was off a little bit, but I think they were trying to shoot for this point. I think. And then that one comes out to 3, 0. Okay? Now, drawing in the XY axis. I think somewhere around there. This should have been moved over a smidge. Okay, but that's for the most part what our graph looks like. Now, I want you to use your imagination. Domain. Domain, we're going along the x-axis, right? We're cruising on this x-axis. We're in our little car. We're going this way and this way. If I go forever to the left, I'm going to have to look pretty far down to see the graph. Do you agree? That arrow is continuing on a downward way this way, but no matter how far I go that way, that graph is going to exist. I turn the car around, say, let's see how far it goes this way. And I'm going to go forever this way. Now, if I go forever this way, I'm going to have to look pretty high up in the air to see the graph still. Does the graph start or stop anywhere? Keeps going and going and going. What's my domain? Negative to positive infinity. So in the x direction, I can go forever both ways and still have a graph either above me, below me, or right on the line. Yeah.
What do you call this graph? It's like a parabola.
This is a third-degree polynomial. So it's x to the third power.
I don't think this is a graph. It's like a squiggle.
Stop.
Mine?
No, the graph. It's like a line. Top to
You know what that graph is used for? Like that graph right now.
Stop.
Well, no. Okay, you ready? Wheaties? Waves?
Whaties?
No. This is a third-degree polynomial, which is in the third dimension. So if I were to take a square piece of cardboard, still with me in this adventure, and I were to cut out each of the corners, the exact same size square out of each of the corners, and then fold it up at each, now I'm creating a volume. And so there's a way that I could cut out a portion of each of the corners to have a maximum volume. And that's what this kind of graph is used for.
Oh, okay.
So, and it's the third dimension is really what it is. It's third dimension represented in two spaces, all it is. Hey, the range. The range. Oops. I'm riding an elevator up and down. This is going forever up. That's going forever down. It has a little bit of wiggle room in the middle. What do you think the range is going to be here? Negative infinity to positive infinity. That elevator goes forever down, sees the graph. That elevator goes forever up, sees the graph. Okay? Right around the origin, there's a lot more action taking place than, if you're way down at negative 100 trillion. If you're down at negative 100 trillion, you have to look out that way pretty far out to see where the graph is. If you get to 158,248,312 upward, you're going to have to look off to the right to see the graph, but it's going to exist both ways. Okay? Increasing. Okay? Increasing goes from here to here, and goes from here to here. There's two places this graph's increasing. So, the first one is going from negative infinity all the way to negative 3. Where's the other one going? It's going to infinity. Where did it start at? Huh? 1.
Wait, what is that? Is that infinity?
Uh-huh. So, starting from here, it's growing. Starting from infinity, negative infinity, it's growing. What is it doing between here and here? Decrease. So, from negative 3 to 1, both x points is where the graph itself is decreasing. Okay? All right, last graph I'm not a big fan of. Go ahead and pass your tests in, make sure your name's on it. Or your quizzes in. Pass them in, pass them forward, make sure your name's on it. Don't look for the one that has number 58 on there because it was a fictitious comment.
Yeah.
Yeah. Pass them in. No, if you didn't, it's okay.
No, they're all on.
Any more? Are you doing all right? Now, guys and girls, I'm not sure how y'all are feeling as spectators, but I think a couple of answers might have been answered on that quiz just now. There might have been a handful of you going, "Oh, that's all it was." Now, there's still some of you that are still trying to figure out, there wasn't a place to put my name. I know. Sorry. Make your best guess. All right. So, I want to continue on our adventure, and this is a shorter lesson. That's why I'm starting it. Learning target. I can write an equation in point-slope form. What are the two words that you see in point-slope? What's one of the words? Point. That means x comma y. With me still? Slope. Slope is the change in the y direction over the change in the x direction. The rise over the run. Right? So I can write an equation in point-slope form. All right, next slope. All right, find the slope between the 2 points. Okay, I'm pretty sure we can go through each of these, but you know that I'm going to do m is equal to 4 minus negative 4 over 5 minus 3. Do the arithmetic, you work that. This is going to be negative 5 minus negative 1, 2 minus 6. Do the arithmetic, you're going to find the slope. Still with me? That's like old school. That's so last week. Okay, write the equation of line in slope-intercept form. Well, slope-intercept form is this. Okay? So on the first one, we already have the slope. The second one, I have x and I have y. And this one says we'll write it to find this. So number 4, we find the slope first, and then we pick one of the points and plug them in for y and x. And then solve for b. And again, goes back to that equation. Again, this is stuff that we've worked on. But I want to move past that. Okay? Given the point 3 comma 4. Okay, I can graph this. 1, 2, 3, up 4. Put a dot. That seem okay? Does that check out? Okay, as far as the slope goes, my slope is 2. I can write the slope as a fraction as 2 over 1. So from this point, I'm going to go up 2, right 1. And I'll keep going up 2, right 1. Up 2, right 1. And when I connect these, let's say perhaps I can graph a really straight line, I can figure that out. Now notice, it does have some b value where it crosses the y-axis. Do I know what it is right now? I just know that it does there. Okay? So all we need is one point in a slope. And remember, a slope is like a map to find another point. A slope is not a point, but it's a map to find another point. So we can use the same information. Okay? So this is the point-slope equation. What does this equation kind of look like, but manipulated a smidge? There you go. Okay? So, things that we're not worried about up here is I'm not worried about this, and this somehow miraculously came over. Okay? That's really what it does. So, when using your point-slope equation, and this is often used in higher math, this x and this y do not have subscripts. So I'm not substituting in for them. If it doesn't have a subscript, a lower number, I'm not substituting in. The slope, a lot of times you can find the slope when you have 2 points. And then x1, y1. When you find the slope of a line, don't you label your points x1, y1, x2, y2? And if you don't, you should. Okay? So we're going to build upon this equation a little bit more with this next slide. Write the equation with a slope of -3. Slope is what letter? M. And then I have this point. I'm going to label this x1, y1. Do I have another point to label? Do I have another point to label? No. So, using this equation, y minus y1, y minus 7, equals -3 times x minus minus 1. X minus minus 1. What's minus minus 1? What's minus minus 1? Minus negative 1. Positive 1, thank you. Write the equation. So right there, that is my point slope form. Okay, I have a slope of what on the next problem? 2 over 5. So m equals 2 over 5. I'm going to label this x1, y1. I don't have any others to label. So I'm going to go y minus minus 8. Y minus minus 8 is y plus 8. Slope is 2 over 5. X minus 10. Oh, that's easy. Done. We're leaving it right now in point slope form. If I solved it for y and got rid of the parentheses, that puts it in slope intercept form, which is y equals mx plus b. But right now we're in point slope form. Slope is this, passes through that point, x1, y1. Still with me? Take a look. Y minus minus 7 is y plus 7 equals 6 times x minus 3. Done. Again, it's in point slope form. Point slope form is an acceptable form if they ask you to leave it like that. If they want you to put it in slope intercept form, solve it. Okay. Slope is 1/2 here. Still with me? This is going to be labeled x1, y1. Still with me? So let's do it in point slope form. Y minus minus 3 is y plus 3. Agree? Slope is 1/2. X I don't know. X1 I know to be 4. So it's minus 4. Do you feel comfortable with that?
Yeah.
I now want to start to solve this. I want to solve it. So I'm going to distribute here. What is 1/2 times x? 1/2 x. What is 1/2 of negative 4? Negative 2. How do I get this y all by itself? What do I have to do with the 3? Subtract it. Cancel, cancel. Y equals 1/2 x minus 5. Now it's the slope intercept form. Negative 5, 1, 2, 3, 4, 5. Sweet. Up 1, right 2. Sweet. Wrap that. There's our line. Okay, so point slope's really easy to use because you're plugging x1, y1 in and plugging your slope in. It's real easy to solve for it. Distribute your slope over the parentheses, then move whatever your y1 is over to the other side doing the opposite math operation. What if I'm not given the slope? I'm going to label this x1, y1. Still with me? What am I going to label this one then? x2, y2. Why is that? Because they're two different points. I'm going to find the slope. y2 minus y1 over x2 minus x1. Plug them in. So I get 5 minus 1, 4 minus 2. I now know the slope. But which one do I plug into x1, y1? I don't know. I think I labeled it. What's x1, y1? 2, 1. Which one should I plug in? 2, 1. Why? I already labeled it that way. So I'm going to go y minus 1 equals 2 times x minus 2. How do I solve that? Distribute 2. I'm packing up. There's time. Add 1. Minus 3, excuse me. There we go. Guys and girls, your assignment for next time is going to be, I just want you to do, let's do worksheet number 7, which is page 86. Okay, I don't want you to do the other page. And all I want you to do for tomorrow is just the evens. On page 86, it's only one page. So it's 1 through 15. Do the evens only. So 2, 4, 6, 8, 10, 12, 14. Got it? Make sense?
Yes.
Rating, you take a picture? That's all I got for you. Guys and girls, quit